The next subsection of chapter 1A is energy source. So far I have talked about the difference between electric vehicle and petrol vehicle. I have talked about what are the performance parameters, speed, torque, etc., etc. Now I get into energy source. Petrol tank is there for petrol or internal combustion engine, it is called ICE vehicle, internal combustion engine, ICE, ICE, not IC but ICE vehicles. And for a petrol, for an electric vehicle, battery and electricity charge in electric vehicles. So this, the battery and the electricity is filled in it, petrol tank and petrol is filled in it, that is the source for this. Let us talk about this source, the difference between the two sources. Remember I had mentioned to you the two are sources, but they are different. In what way is it different? Petrol tank or battery should be appropriately sized to support the required drive. I want to go 150 kilometers, 200 kilometers, 250 kilometers without having to refuel either with electricity or with petrol. So my petrol tank should be so large that I should be able to drive 250 kilometers, or my battery should be so large that I have enough electricity to drive 250 kilometers. So it will depend on the required drive, that is a user requirement, and from the user requirement you decide what is the petrol tank size or battery size. Otherwise will require frequent fill up or frequent charge, which generally you do not like. How should one size them? So it depends on parameters. First of all, how much energy you want to go 250 kilometer, how much energy is required on the average per kilometer. Of course, you will say if you accelerate more, you will require more. Take average, and that is a concept of what is called drive cycle will come in. So based on that, you sort of say this is the amount of petrol that you will require per kilometer, and therefore you want to go 250 kilometer, put some buffer, and that is the amount of petrol that you need, and the petrol tank has to be appropriately sized. In a very similar manner, you will say how much battery energy is required per kilometer on the average, and you say okay, so much distance you want to travel. So this is the size of the battery that you need on the average. Of course, remember I talked about different kind of drives will require different amount of energy. If you are, for example, climbing a hill, of course the energy requirement will be much more. So you won't be able to go to the same distance. So some kind of average that you will take. The other question sometimes very often has to be asked, how much do you drive per day in a vehicle? You don't want everyday fill up. So in a single drive you have to worry about long drive or how much drive you do. How much do you drive per week? These are the questions, and what kind of terrains that you drive. So what is the user convenience for battery, fuel tank charging or battery charging? Fuel tank charging is like filling petrol, battery charging is like filling electricity. So these are questions that you have to ask in deciding what should be the size capacity of either a petrol tank or a battery. Now, petrol tank, as I pointed out, is easier. Life of the petrol tank and battery in terms of years. In terms of how often can I use it? Can I keep on filling and using it, filling, using it, filling, using it? In a fuel tank, petrol fuel tank, costs are very low. It is a kind of container, and life is long. You can talk, I mean occasionally the fuel tank may leak, but 15 years, 20 years, they are not designed well enough such that fuel tank life is long, costs are low, does not contribute too much. Of course, it consumes size in the vehicle is important, but otherwise not that bad. On the other hand, electric battery is very different. First, battery capacity, you start buying a battery and the battery capacity keeps, as it gets used, capacity gets reduced. Now, every time you charge, discharge, the capacity gets reduced. Every time you charge, use it, capacity gets reduced. Capacity. So, if in the beginning, if you are getting 100 kilometers, after some time you will get 90 kilometers, you will start getting 80 kilometers, 75 kilometers, and then this battery is no good anymore, I might as well buy a new battery. So, it is defined by what is the charge discharge cycle. This is the number of cycles before it needs to be replaced. And replacement typically happens when you lose 20 to 25% of capacity, and that could be 700 cycles to 3000 cycles, could be even more. Of course, battery will become expensive. Less number of cycles, battery will be inexpensive. More number of cycles, battery will become expensive. So, quality of battery cost will change. Then there is also called calendar life. Even if you do not use it, it starts deteriorating, and there is a finite life. If you use it, of course, cycles will deteriorate. Even if you do not use it, you will keep deteriorating. So, you have to actually do a combination of calendar life and charge discharge cycle life, and it is a combination, sort of say, well, that is the cost, that is what you have to sort of say it is going to last so long. Next, it is very expensive. 1 kilowatt hour battery in India, for example, costs around 15,000 rupees to 20,000 rupees. Now, how many kilowatt hour you require? Now, I will come to what is kilowatt hour, but this is a unit of electricity. This is what you say at home, 1 unit of electricity you pay about 6 rupees or whatever. So, battery is also size depends on how much unit of electricity can it store, and it is 15 to 20,000 rupees, and you have to probably store large number of units, battery costs can go up like anything and significantly contribute to the vehicle cost. Petrol tank cost is very low and is largely one time. So, on the other hand, if I look from a fuel point of view, tank cost was low in petrol tank, high in electric vehicles, but usage petrol per se is expensive, 100 rupees per liter, it is going up beyond that, and therefore, all the time you have to worry kitna deti hai, how many kilometer will you drive per in a liter of petrol. This is a very important question. And if you can drive 10 kilometers, that means 10 rupees per kilometer you are spending. Of course, it depends on the type of vehicle. If it is 2-wheeler, it will give you consume much less per kilometer. It is a 4-wheeler, very big vehicle, it will consume more. It will depend on the type of vehicle energy efficiency, liters per kilometer, and typical drive cycle. Are you going to mostly accelerate, decelerate, or go flat at constant speed? Will you drive slow or drive a little fast? So, that will determine the amount of energy you consume per kilometer, and a medium sized car, as I told you, consumes about 10 kilometers per liter. Cost is high, so 10 rupees. On the other way, electricity cost is low, 5 rupees per unit, 6 rupees, 7 rupees, 8 rupees per unit. So, that is the cost of the electricity. I am not talking about battery cost, this is the fuel cost, then you fill up the battery. And the same question will ask, per kilometer how much energy do you use, how much kilowatt hour do you use. Again, depends on the type of vehicle, vehicle efficiency, typical drive cycle, how much I accelerate, decelerate. I have been driving a vehicle for last 5 years, electric vehicles, and it consumes about, on the average, it gives me for 1 unit of electricity 8 kilometers. So, just look at it, even if I pay 8 rupees per kilowatt hour, and I do not pay 8 rupees, I actually pay 5 rupees, my cost is 60 paise per kilometer. Whereas you are driving a vehicle, you are paying 10 rupees per kilometer. Yes, to get the battery first time I have paid a high amount. For fuel tank you have paid low. But per kilometer you keep on paying more and more. I don't pay as much. Ideally that would have been enough, but the problem is my battery also will run out. So that big cost that I have paid, I have to again pay. After 5 years, 6 years, 7 years, after driving so many kilometers, I have to again pay. So I have to worry, it gets complicated. As I pointed out, for petrol vehicle one may draw petrol from fuel tank at whatever rate one requires. You want to accelerate, you draw more, it does not hurt, pipe and the injection rate does not add costs, wear, tear, anything. Not so for battery. Battery, if you charge faster, you can fill the petrol also very fast, take out water at fast. Not so for battery. Batteries you should charge slow. You should draw out currents slow. Charge rate, discharge rate needs to be slow. If you don't do it, you can do it, but then the life gets further reduced, which means again you have to pay. So, charge discharge rate impacts life of battery. Complicated, not so in fuel tank. As battery voltage is constant, current is proportional to power, so you draw more current, less current, and your battery life will depend on. In fact, what is called battery life is dependent on charge discharge rate, or what is called C rate. We will define this C rate more. It is a charge or discharge rate, C rate, charge rate. It also depends on the temperature. For petrol vehicle, not much dependent on temperature. Here, if temperature goes up, the battery life goes down. If temperature goes much lower than a certain value, again battery life goes down. So batteries behave best at 25 degrees centigrade plus minus 5 degrees centigrade. Below that, batteries do not behave very well. Above 30 degrees centigrade, it does not behave very well. So 10 degrees, 5 degrees, 0 degree batteries do not behave very well. But we India have less of a problem. That is a problem of United States, Europe, even China. But on the other hand, if it is 35 degrees centigrade, batteries do not behave. 40 degrees bad, 45 is very bad. So we have the problem on one side, they have the problem on the other side. So temperature and whether I charge or discharge or even keep it, temperature impacts life. Even if battery is sitting idle, the life cycle degradation increases at higher temperature. Then there is something called, it is a very peculiar thing. In petrol vehicle you fill the petrol. In battery if you fill it completely, life is not good. And that is measured by a parameter called depth of discharge. You do not fill it completely. Maybe you fill it up 85%, 90%. Do not fill it to the rim. One will say if you fill something to the rim, things move, it can spill out. Now fortunately that petrol vehicle that is not so, it is just covered. In battery there is a spilling out. If you fill it full, life is not good. Similarly, if you empty it fully, life is not good. So you sort of say you never fill above 85%. You never empty it below 5%. You must have seen it in your battery, laptop or cell phone batteries also. You never, it's the same battery, never fully empty, never full. So to that extent, you are not using the full capacity. You thought you will get 100 kilometers, but you are leaving 15% the top, 5% the bottom, you are getting only 80 kilometer range. And then you have to fill it again. So, all these things makes things complex, and we will discuss these things in detail in the course. To sum up, in a petrol vehicle, the container costs are low upfront cost, container requires rare replacement, fuel costs are high. In electric vehicle, the container costs are very high, the battery costs, high upfront costs, and then on top of it battery requires replacement, 4 to 8 years, depend on the charge discharge cycle, operation temperature, depth of discharge. But the good part is fuel cost is very low. Also it is environmentally friendly, so all those things will add significantly. We will also talk about what the trend is, how things are moving, but that gives you an overview of the most important part, the energy storage. And energy storage plays a very important role in the vehicles.